Alrighty, so next up we're going to take a look at graphing linear equations, graphing linear functions, and we're also going to take a look at graphing linear inequalities. Okay, so each of these equations is kind of written in a different format, so we'll go through how to deal with each one of them. When I look at problem number 8, I've got y equals negative 2x plus 1. Well, that is y equals mx plus b. That is slope-intercept form. So that means my slope is negative 2, or negative 2 over 1, and my y-intercept is at the point 0, 1. Okay, the b value is 1. All right, so I'm going to go 1, 2, 3, 1, 2, whoops, 1, 2, 3. And you can use any scale that you want as long as you are labeling your scale, okay? But you always want to label at least one number on each axis so that we can tell what you're counting by. Now my y-intercept is at 1. So that's on the y-axis. We have a dot at y equals 1. Now my slope is negative 2. That means I need to go down 2 over 1. And the over 1 is always to the right. Remember, this is a negative slope, so the line should be going down because it's a negative slope, okay? So I need to go down 2 over 1. This is my new point, okay? So I have the point here. Then I'm going to go down 2 over 1 to get to my next point. You always want to have at least 3 points to make sure you're counting your slope right. I could also go up 2 and backwards 1 to get to a point as well. You can always go backwards if you do everything opposite. All right, and then I just use a ruler and draw a line. I don't have a ruler, but I can snap it in like this. And we should draw arrows to indicate that the line extends beyond the graph that we have. This line goes on forever and ever. Okay, so that's graphing in slope-intercept form. Now, when you're graphing standard form, 3x minus 4y equals 24, you could rearrange it to slope-intercept form, but if the y-intercept isn't pretty, if it's a fraction or a decimal, that could be difficult to graph. Here, what I'm going to do is I'm going to find the x and y intercepts. To find the x-intercept, that's going to happen when y is 0. So if I pretend this isn't here, okay, if I pretend that's not there, I'm going to get 3x equals 24. So that means x is equal to 8 when y is 0. X is equal to 8 when y is 0. Okay, so I cross off the y because I was doing y equals 0. Now I'm going to go through and I'm going to find the y-intercept. Y-intercepts happen when x is 0. So that's like having the x term not be there. So now I have negative 4y equals 24. That gives me y equals negative 6. Okay, so that means my y-intercept is a point 0, negative 6. Now all you need to graph a line technically is 2 dots. Okay, so I can go ahead and I can graph this using these 2 dots. Let's see, I'm going to do it in green. Now I'm going to scale this so it's easier. I'm going to go by 2. So I'm going to go 2, 4, 6, 8. 2, 4, 6, 8. Now, my y-axis, I'm going to use the same scale, but I didn't have to. I could switch it up if I wanted to. So I'm going to go 2, 4, 6, 8. 2, 4, 6, 8. Now, my y-intercept is 0, negative 6, which is down here on the y-axis. My x-intercept is positive 8, 0. And then I want to draw a line in between those. Oh, I'm a little bit off. Let me try drawing that again. That's a little bit better. And then again, put arrows on the ends to indicate that it goes beyond what you've drawn. Okay, so if you're doing slope-intercept form like in number 8, you want to have at least 3 points to make sure you're counting your slope correctly. If you're going to graph using x and y intercepts, just be very careful when you plot your lines, plot your points to make your line. All right, this last one over here, y equals negative 2. We talked about when we have y equals a number, well, that's just a vertical or horizontal line. The question is, which one is it? Well, if I look at y equals negative 2, okay, 1, 2, 1, 2, 1, 2, 1, 2. Y equals negative 2 is right here, and right here, and right here. All of these points have a y value of negative 2. So this is actually going to be a horizontal line. X can be anything you want. Y will always be negative 2. So I'm going to draw a horizontal line going through all these points. And again, I want to extend to show that it keeps going. And we should have a nice horizontal line there. Okay. So that's graphing linear equations. The reason it says graph the linear equation, not linear function, is if it had been a vertical line, then it wouldn't be a function because it wouldn't pass the vertical line test, okay? But most linear equations do work out to be functions. It's only a vertical line that will not pass the vertical line test when it comes to linear things. All right, now let's talk about inequalities. So how is graphing a linear inequality different? Well, we still graph the linear function, but now there are two things to consider. We've got to decide, should the line be solid or dashed? And that's if we see equal to, we use a solid line, just like closed circles with inequalities. Okay, and that means the points on the line are actual solution points. And then if I see y is less than or y is greater than, no equal to, then we're going to use a dashed line to represent like an open circle, that there are points on the line that are not solutions, okay? So that's the first one we consider, solid line or dashed line. Then we also need to think about, well, do we shade above or do we shade below? Because we know when we do open and closed circles, we either go to the left or go to the right. So if we have y is less than, we're going to shade below the line, straight down. And if we have y is greater than, we need to get to bigger y values, we need to go up, okay? You could also pick a point not on the line and test it in the inequality to see if it gives you a true statement. If so, you would shade that side, and if not, you would shade the opposite side. But don't use a point on the line because that doesn't tell you which way to shade. That's something directly on the line, which we already know if it's going to work or not based on the equal to or not equal to. All right, so let's take a look at a couple graphs for these. So we're going to graph each linear inequality and pay careful attention to the type of line. All right. We're going to also state a solution and a non-solution. So we're just going to identify coordinate points that actually work for the shaded areas. All right, so problem number 11 is in standard form. I'm going to go ahead and I'm going to do x and y intercepts again. So when I do the x-intercept, pretend like the y isn't there because y is 0. And when I solve this, I'm going to get x equals 4. Okay. Then I'm going to go ahead and I'm going to do the y-intercept as well, which means x is 0. And if I pretend the x isn't there, I'm going to get y is -3 by dividing out that -4, okay? So that's getting my x and y intercept so I can make a graph. So now if I make my grid, not great, probably should have straightened them out, but 1, 2, 3, 4, 1, 2, 3, 4. And you can see that these are sketches. These are not perfect graphs. Okay. So I've got the point 4, 0 and -3. 0, -3. Okay. Now, is there an equal to? And the answer is no. There's no equal to. So this is going to be a dashed line inequality. Drawing a dashed line straight is not always the easiest thing. It is okay to draw a solid line and write right next to it the word dashed if it's not clear that it's a dashed line. Now I got to figure out which way to shade, but I don't have the y by itself, and I don't want to go through and do that algebra of rearranging it if I don't have to. So I'm going to test a point, and I'm going to test the point 0, 0, because it's the easiest numbers to plug in. So I'm going to get 0 minus 0 is less than 12. Is that true? Yes, it is. That means 0, 0 is in my shaded area, so that means I'm going to shade where that point is. So I'm going to shade everything over here. That means all of these coordinate points are solutions to this inequality, not including the points on the actual line itself because it's a dashed line. So when it comes to a solution, I could say the point 0, 0 was a solution, and then a non-solution would be something over here. So I'm just going to go big, and I'm going to say it's 10, -10. Okay, which is clearly off my grid, but definitely going to be below the line because it's further to the right and further down than my x-intercepts. Okay? All right, let's go through problem number 12. On this one, I'm going to go through and I'm going to divide out the 6 because I'm so close to having y equals mx plus b. 4 over 6 is 2/3. And then 18 over 6 is 3. So that means my slope is 2/3. And my y-intercept is at -3. So if I go to make this grid, let's see, I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's a -3, Miss Morrow. Okay. So my y-intercept is at -3. And I need to go a slope of 2/3, so that means up 2 over 3. And then I would do it again, up 2 over 3. I'm a little bit off my grid, but that's okay. And then because this inequality symbol has an equal to, I'm going to draw a solid line this time. I'm going to move that point because it's clearly a little bit off. Okay. So let's fix the point. It's going to be, actually, well, you get the gist, okay? It's not going to be perfect because I'm not using graph paper. All right, but on the test, I would probably give you a grid to plot this on. Now I need to think about shading. Now let's take a look right here. This says that y is less than or equal to. So I need to get to y values that are less than or equal to the points on my graph. So pick any one point you want, and you want to go straight down from it. And that's where your shading goes. Pick a point, go straight down. That's where the shading is going to be, okay? So I'm going to shade below the line like so. All right. So then when it comes to a solution and a non-solution, okay, a solution could be any point on the line or any point in the shaded area. So I'm going to go maybe, what do we see here? I'm going to go straight down. So that solution could be 3, -3. And then for a non-solution, I'm going to go with the origin 0, 0 as a non-solution, okay? So that's how we deal with inequalities.